In this tutorial, I'm going to give you an introduction to Apache Spark using the typical Apache Spark Hello World example, which is a word count example. So the first thing I'm going to do is clone the tutorial from GitHub and then run Docker Compose. And while that's starting up, I'm going to open the tutorial in Visual Studio Code so we can take a look at the Docker Compose file. So this example is pretty straightforward. We're running only a single container, which is this Docker container that I built called Spark-Notebook, and the version is 2.0.0 preview, so it's running Apache Spark to the Apache Spark 2.0 preview. The other thing that we're doing is we're mapping a local data directory to user data in the container and a local notebooks directory on user notebooks. So you'll notice in this notebooks directory, this is the local notebooks directory. We have this word count notebook, and that's what we're going to walk through in Apache Spark. And in the local data directory, you can see we have the Back to the Future transcript. That's the data we're going to work on. So let's go ahead and jump into the notebook. Okay, I'm going to walk through Apache Spark Hello World, which is essentially word count. In this example, I'm going to do something a little bit different. I'm going to use the Back to the Future transcript. So the Back to the Future transcript is formatted as character followed by a colon, then followed by the line that the character is to speak. So that's important to note because in some cases we're going to want to filter that information out, and in other cases we're going to want to use that information. And I'll explain why in a second. So this notebook is essentially made up of three parts. The first part is your simple word count example. We're just going to find the most common words used in the transcript. The second part, we're going to filter out common words or stop words. So very similar to the first example, but just getting rid of common words like the, so on and so forth. Finally, we're going to find the most common word spoken by each character. So what was the word that Marty said the most or Doc said the most? So let's start with the simple word count. So I'm going to walk through this notebook. The first thing we're going to do is import the Python regular expression package. All right, the next thing we're doing is we're calling text file on the Spark context and passing in the path to the Back to the Future transcript. So this function will return an RDD of strings. Each string will be a line in the text file. So essentially we're breaking the text file up into lines. Now here we're just defining a function that we'll use to break each line up into words. And you'll see this function does a couple of things. The first thing we do is we strip out the character, meaning Marty or Doc, because we don't want that to interfere with our simple word count right now. The second thing we do is we strip out any special characters like semicolons and commas. Then finally we split on spaces and return the list of words. So in this cell, we're taking the lines RDD, which remember is RDD of strings. Each string is a line in the file, and we're calling flatmap. So the flatmap function allows you to take an input and convert it to 0 or more outputs. So if you perform a typical map function on an RDD, it's a one-to-one function. You're just changing what the data looks like. But with a flat map, you can return as few or as many RDDs as you want. So in this particular case, we are going to take each line and convert it to many words using flat map. So now our words is an RDD of strings, but it's of every single word. Right. So as I mentioned, with the map function on an RDD, you're essentially just mapping. You're changing the way the data looks, but every input there's one output. So what we're doing here is we're taking every word and we're converting it into a tuple that has the word and the number 1, and we're going to use that in the next step to count the occurrences of each word. So in the next step we're calling reduce by key. Reduce by key takes two values that share a common key. So for example, if the word the showed up in the previous step, we now have RDDs that would say the, comma 1, the, comma 1, so we would have maybe 10 of those. So reduce by key takes two at a time and passes in the value for each one. So the first time it's called, it'll be 1 and 1. And what we'll do is we're going to return 2. And that's this x plus y. So now you've just reduced the comma 1 and another the comma 1 to one RDD that's the comma 2. The end result of this is you're getting the count for every single word. And at any point, if you want to see what your RDDs look like, you can always call take. You can take like the top 10, and you can take a look at what you're working with. This is great if you're new to Spark like I am, and you're losing track of what your RDDs look like. So in this particular case, the word electrical showed up 4 times. If we actually backtrack one, and before we do the reduce by key, you can see we're just creating tuples of each word with the count of 1. So in any cell, if you want to just see what do my RDDs look like, just do a take, and then you'll actually be able to see what you're working with. Okay, so now that we have the word counts, we want to find the most popular words. So in order to do that, what we're going to do is we're going to reverse our RDDs. So right now our RDDs, the key is the word, then the value is the count. We're going to swap those. So that's what this map is doing here. And again, I'll take 10, you can see what that looks like. So you see we just swapped the values. So now that we've swapped the values, we can sort by key, and we want a descending sort, so we'll say ascending equals false. And then, like I've been doing, we're just going to take 10, and here we're going to see the 10 most popular words in the transcript. So you can see those words are you, the, I, to, it, that. So these are common words. So this doesn't really provide us any insight into the transcript. So the next part, what we're going to do is we're going to filter out stop words. So you can use pip inside a notebook to install packages. So we're going to install the stop words package. And we're going to import it. And now we've created a new function to parse each line. And the biggest difference in this function is these last 2 lines where we filter out any word that's in the list of stop words. We're using English stop words for now. The transcript's in English. So we're going to do a flat map just like we did before. The difference is we're passing in the parse line 2 function instead of the parse line function. Now while those are executing, here we're doing the same thing we did above, where we map each word into a word comma 1, and then we do the reduce by key to get the total count for each word. We're just combining it all in one line. And we're doing the same thing that we did above here too, is where we're reversing the RDDs and then sorting descending. And now we're going to get the top 10 words again. And this time, they're going to exclude those common words. Okay, so you can see the most common word in the transcript is Marty, and the second most common word is Doc. All right, so that's pretty interesting. Let's dive a little deeper. So in this next part, what we're going to do is we're going to look at the words spoken by each character, so we can find the most common words spoken by each character. So we're going to start a little bit differently here. We can't really read the file line by line because some of the lines spoken by characters span multiple lines in the file. So in order for us to associate every single word spoken in the transcript, we're going to have to read the whole thing in at once and do some regex magic to associate each word to a character. So instead of calling sc.textfile like we did before, we're calling whole text files. So what that will actually return is RDD, the file name, and then the file contents. So we're going to define this function that takes the entire contents of the file, and essentially it goes line by line, finds the next character in the list, and then every word that comes after that character gets associated to that character until we find another character. So here we're just taking that contents, and we're calling that parse contents function here. So there's no Spark anything going on here. We're just using pure Python to parse the entire contents of that file and create a list of character word tuples. All right, so we want to convert those character word tuples into RDDs. So we call the parallelize function to do that. And like I mentioned before, let's take 10 just to see what we're looking at. So there's a character in the transcript called radio. So that's the first thing that actually happens in the transcript, is something's going on in the radio. So on the left, you're actually seeing the character. On the right, you're seeing the word the character spoke. In this case, the character's radio. So we're going to do exactly what we did with the other word count, where we're going to map this RDD. We're going to add a count of 1 for each one. And then we're going to do like we did before. We're going to reduce by key. So essentially what we're going to get is the total count of each character word combination. So you can see, unlike before where we just had a word and then a count, here we have the character, the word the character spoke, and then the count. So Marty said girls twice. Doc said Scott 3 times. Okay, so we're going to do like we did before. We're going to reverse the RDD, so the count is the key. And then we're going to sort. And then this is going to give us the top 10 character word combinations. So Marty spoke the word Doc 53 times. That was the top word spoken by any character, and that character happened to be Marty. The second top word spoken by any character was by Marty. The third was George by Marty. The fourth was yeah by Marty. And the fifth is Marty by Doc. All right, so this is cool, but this isn't exactly what we want. What we want is the top word spoken by every character. So in order to do that, we need to restructure our RDD, because what we really want is our character to be the key. So that's what we're going to do here when we call this map function. So I'm going to do that, and then I'm going to show you what the RDD looks like after we do that. So now Marty becomes our key. That's the character that spoke the word. And then our value is a tuple that contains the word the character spoke and then the count. So we're going to do reduce by key again, but this time it's going to be a little different. We don't just have a value that we can add. What we're going to do here is, remember I mentioned when you call reduce by key, you essentially get 2 values passed in. The key is the same, the values are different. So let's take these top 2 for example. We're going to get passed, this function is going to get passed with doc 53 and 28. And we have to determine which one do we want to keep. This function down here, what we're doing, we're saying, remember x is the first value, y is the second value. So we're saying we're going to return x if x of 1, which is the count, 53 for example, is greater than y of 1, which is the count for the second value, 28, which in this particular case would be true. So if this got called with Marty with this value and Marty with this other value, then this top one is going to be the one that gets reduced to. So then we're going to reverse the RDD again so that the count is the key so we can sort. And finally, here we go. So Marty, as we already knew, the most common word Marty said was Doc. The most common word Doc said was Marty. Biff, his most common word was McFly. George's most common word was Biff, and Lorraine's most common word was Marty.